Hello and welcome to our third lecture in this series, sequence of sets. A sequence of sets xn is called increasing if x1 is subset of x2, subset of x3 and so on, and decreasing if x1 subset of x2, subset of x3 and so on. So in other words, a sequence increasing if the sets in the sequence increases in size, and if it decreases then it's decreasing, right? Now the definitions: limit superior and limit inferior. Please reread. The upper limit or limit superior of a sequence of set xn is the set of points which belongs to xn for infinitely many values of n. Limit superior is denoted by lim sub xn. And the lower limit or limit inferior of a sequence of set xn is the set of points which belongs to xn for all but finitely many values of n. Limit inferior is denoted by lim inf xn. As a definition, one says points belong to xn for infinitely many values of n. In the other, all but finitely many values of n. In both the cases, points belongs to infinitely many xn's. So what is the difference? Well, try to figure it out on your own for 5 minutes. We'll see the justification a couple of slides. From the definition, it is clear that limit xn is subset of lim sub xn. Remember, in lim inf, points consist of points that belongs to all but finitely many. That means if x belongs to limit xn, then x belongs to all the xn but finitely many. That means x belongs to infinitely many xn, and hence x would belong to lim sub xn, not the other way around. Well, I have already give you the argument, but still stop the video and try to have your own argument for the sake of it. Okay, we can think more rigorously by picking examples. I have given you some examples. You can have your own examples. For example, you can have x1 to be 1, that's set 1, x2 set containing 1 and 2, x3 containing 1, 2 and 3 and so on. Then you can try to see what would be lim inf and lim sub in this case, or you can try something like this: x1 contains 1, 2, 3 for all the natural numbers, x2 contains all the even natural numbers 2, 4, 6, 8 and so on, x3 all 3, 6, 9, 12. You can think of this as natural numbers multiplied by 1, 2, 3 and so on. And again, try to have lim sub and lim inf of all these xi's. For a sequence of sets xn, if we have this lim inf equals lim sub, let's say it is x, then x is called the limit of the sequence as denoted by lim x, limit xn or lim xn. Proposition: lim inf of xn is in fact union of intersection of xn. But remember, the first union is up to k from 1 to infinity, but the second goes from k to infinity, not 1 to infinity. Suppose lim inf xn is x star and let x belongs to x star, then by definition x belongs to xn for all but finite number of values of xn. Suppose k minus 1 is the largest value of n for which x does not belong to xn. We know that x does not belong to xn for some finitely values many n. So if of all these finite numbers k minus 1 is the largest, that means x belongs to x k, and all the other n larger than k. That means x belongs to intersection of n equal to k to infinity x n. And this implies that obviously x belongs to the union, and hence x star is a subset. On the other hand, if you pick y from this, then being union of this, y would be intersection of xn. That means y belongs to all these xn. Or in other words, y belongs to all the xn's except finally many values of n. And hence y belongs to x star. So we have this from 1 and 2. And where is it? Similarly, you can define lim sup as intersection of union of x. The proof exactly the same. So write down your proof. Well, let's stop for a minute and try to think about lim sup and lim in. Let's resume. So once we have the definition, we have this proposition: if xn is a decreasing sequence, then limit of xn is in fact intersection of all these xn's. Since xn is decreasing sequence, clearly you have union of xn starting from k to infinity is xk, because all xk plus 1, xk plus 2 and so on are subsets. So xk is the largest, so their union is simply xk. Now, for the proposition of lim sup xn is union intersection of all this xk. In other words, intersection of xn. Next, well, mistake. Next, for each k, intersection of xn starting from k to infinity is same as intersection of xn starting from 1 to infinity, and let's say a. Now, if you look at the proposition of lim in, then what we see that lim in is described by this, whereas this is nothing but a. So all those unions of a is simply a, and a is nothing but intersection of xn, intersection starting from 1 to infinity. Thus, what we obtain that lim in and lim sup are the same. That means limit exists and limit xn is intersection of xn. Same way, if you have an increasing sequence, then limit is simply the union of xn. Up to you to prove. Now consider a concrete example like xn is open set 0, 1 over n. Find limit xn. Well, you already know that xn by definition is decreasing. So for a decreasing sequence, if limit exists, it has to be intersection of xn. So first, try to see that limit exists. And once limit exists, you have intersection of xn. And xn, you can clearly see that they are decreasing in size. So the smallest xn as n goes to infinity would be an empty set. Well, why? If possible, it's not empty. And then x belongs to this intersection, say. Therefore, x is positive by definition, and x belongs to xn for each n. But Archimedean principle of real numbers say that you will find a positive integer m such that x is greater than 1 over m, x being positive. This implies that x does not belong to xm, the set, which is a contradiction because we have assumed that x belongs to each of these xm. Then we can try the same problem as I have said. To show that limit exists, you have to show that lim sup xn, lim in xn, and both of these Question mark has to be the same. Have fun. Thank you.